Hello, good morning. Thank you for joining me in my shop here. It's December 16th and 0 degrees outside and going up. And 9 degrees yesterday here. Snow is gone. Rain is probably going to fall later today. You wouldn't know it's winter at this point. So, okay. Surprisingly enough, to me, this radio works really well as it is. Really surprised by that. Yes, I had to change some tubes to make it work, including one totally incorrect tube, which is a mystery about how it got in the radio here, but it was in there. So, just on that note, I'm guessing what happened was the original tube was removed. Sometime later, somebody found the empty tube socket annoying and stuck a handy tube into it to fill it up. And maybe they were in the process of selling this. I don't know. Who knows what would really happen? But somehow, this thing had a 35W4 rectifier tube stuck in where a 6F6 output tube should be. Yikes. So, what to do today with a radio that's largely working? And I think what might be worth doing is a few, I guess we could call them health checks. You know, what's the B plus voltage? Is the B plus and screen voltage distributed through the radio? And what about the blocking capacitor on the output tube grid? Is that still blocking or not? Those kinds of things. So to do that, we got to get underneath the radio here. And unfortunately, although good, I've got a schematic. Bad, I've got no other written information for this radio, such as alignment instructions or anything like that. And look at that. I mean, this radio worked quite well yesterday. It's just loaded with wax capacitors all over the place. My light is flickering in case you're seeing for unknown reasons. Okay. Well, I think we should start with the output tube. Now, the output tube is this socket right here. Am I pointing at the right one? Yes, I am. This socket right here. You can already see there's a wax capacitor here. There's another one here. So this capacitor is coming from the volume control here and heading over to this tube, which is the Q tube. It's a 6 SQ7, I believe, if I remember right. And it's connected, I'm sure, to the grid of the triode. Then there's going to be output from the plate, which will be snapped up by a capacitor and shot over to the grid of the output tube. And look, there's two capacitors coming over. Wow, there's a lot of things hooked up to this spot. I think this is a ground point, so I don't think these capacitors are bringing anything over. How's it getting there? How is the signal getting there? Well, we won't worry about that right now. What I'll do is I'll just look in the tube manual and we'll figure out which pin has the grid on it. And then we can hunt down the capacitor. Or maybe I'm mistaken about this terminal. So 6F6. 6F6. Pretty common output tube. 6F6. Metal type and glass octal. So I've got the metal type in there. Here's the diagram right here. The grid is on 5. The grid is on pin 5. Okay. Look at this. I'm not going to close the book. I'm actually going to keep it open. Grid 5, eh? Let me get a pointer here. Grid 5. So, first of all, I've got to find the... Okay, so I think the key is right here, but it's just a little too dark. Okay, I'm going to blast it with the super light. Yeah, that's where it is. Okay. There's 1, 2, 3, 4. This is 5. So coming off of here should be a capacitor. There's a capacitor right here. This is very oddly done too. Like the wire comes up a short distance and then this capacitor is attached. It's very strange. Is that a wire? Maybe it's not a wire. No, it's not a wire. It's a resistor. Resistor, capacitor, probably the ground. And then behind here is another resistor, a little hard to see, this one here. That's a 500K basically. 500,000 ohm resistor here. Going to a terminal, that goes to a terminal, that goes to a whole bunch of stuff. I guess this is also a ground terminal, we can guess. A grounded terminal. I can see the ground wire from this terminal. And coming back over to this one, well, now I see a capacitor attached to the ground terminal. This can't be a ground terminal. You wouldn't attach a capacitor between two grounded terminals. So it would look like this is probably the plate then. What's this guy doing? What's going on? We got to look at the schematic. I'm not sorting this out properly at all. Okay, let's have a look at that schematic and see if it'll fix things up. Okay, so 6F6 is here. Now pin 5, so you can see the little key is sticking up here. It's a little hard to see. I can zoom this in. We don't have to see the whole schematic here. So there's the key. So we go 1, 2, 3, 4, 5 to the grid. The grid should have a capacitor coming straight off it. We didn't see that. We did see the 470. I called it a 500 just for convenience. It's actually 470. The M here is actually stands for mille, which is French for 1,000. This is actually, we would normally write a K here. 470K, it's not 470 megohms. If they wanted a megohm, they write the word meg in there, so you can't get confused. This arrangement is different than what is in the actual radio. Or did I see it wrong? So this resistor goes to the chassis. That makes sense. And what's going on here? So this is the incoming power here, incoming B plus voltage, and it's applied through this resistor to the plate here. And by the way, this is the capacitor I'm aiming to test, or I want to determine if this is good or not, and probably change it no matter what. Tied directly to the grid. I think somehow they flipped this around somehow, and they've got something wrong in here. I mean, you can't get it very wrong before things stop working. Like if you were to somehow attach this resistor here by accident, then you'd get no B plus to the plate over here, and this tube wouldn't work. Mystery. We have to look more closely at what is in the in there. Why did they write G here? They didn't write it in any other tube. G. I don't know. You put the G there, and somebody says, no. Write the G's. Write them in the circle. Oh, okay. Well, they would have erased that. They would have erased that. Don't know what it means. We can see the cathode resistor here is 390. We should be looking for that too while we're staring at this tube. Okay, let's get a close-up camera on it, and we'll look at this arrangement. Is it really a capacitor to a resistor and a resistor? Or is it two resistors coming off here? Okay. Okay, now I think the automatic focus is running on the camera, so we might have a bit of a hassle here with it. Oh, it looks pretty good. Okay, first of all, did I count them right? So I think the key is nowhere in sight, so it's got to be down under this capacitor here. Let's flip that up. Okay, so we clearly see where the key is now. So we go 1, 2, 3, 4, and 5. Here's 5. We come over. We see a resistor for that pink color is actually for 47, 470. Okay. Now, what else is connected to that pin? A resistor. It comes up to the capacitor. Just what I said I saw. And what's the value on that resistor? Can we get at it here? Where'd it go? I don't think I can get it on camera here. Maybe this way. Come on, autofocus, do your thing. So it looks like green. Green, black, red. So that'd be 5,000. Wouldn't that be 5,000? 5,000 ohm resistor. And there you can see the connection that was made. And then, so thinking is this terminal is the plate terminal of the 6Q7 because of this capacitor is connected to it. And this would be peeling off the signal. That'd be the plate resistor there. What's this other capacitor doing? Coming into the next pin. The next oh look, it's open. There's no tube pin in it. Okay. That's what it's doing, coming over there. They're just using it. So there must be something else connected to it. It's really hard to see what's going on here. Oh, I see it. There's a wire coming off and going up this way. There's another wire in behind it, going around behind it there. That's making it all a little tricky to look at. What to think now? Why would somebody do this other than making a mistake? And that's put this resistor here. Put a 5,000 ohm resistor ahead of the capacitor. Okay, occasionally there's problems with oscillations that can be solved by putting resistors in the grid circuit, like you see here. Could that be what this is? And if you took away the resistor and just put a capacitor like it shows on the schematic, you might open yourself to some kind of oscillation. And this is some guy's trick to solve the an oscillation, a howling radio. On the other hand, trick to solve means some repair was made. And this radio looks like nothing whatsoever has been done in it. So that would have to be original. You know, if you had put this capacitor in and soldered it down to that terminal down there, and then later wanted to add this resistor, it would end up looking just like this. You would lift the capacitor off the terminal. The capacitor's wire would be a little short, but enough here. And then you'd solder the resistor down there and tie it back to the capacitor. You'd have this arrangement here. So the reason I'm quiet is I'm thinking, well, what do I do about it? I'm probably going to change that capacitor. There's a good chance a 5,000 ohm resistor is pretty meaningless at that point in terms of operation of the radio. Because essentially you've set up a voltage divider there between the 5,000 ohm resistor and the big one you can see at the bottom there, the 500,000 ohm resistor. So the vast majority of the signal is going to drop across that big resistor, which is where you want it, because then the voltage will be applied to the tube pin, and the voltage dropping on the resistor is next to nothing. I think this is what this is. I don't know how else to interpret this. It doesn't match the schematic. Could this be a factory solution to an occasional problem? So in other words, radios come off the line and once in a while they oscillate in the audio circuit here, and the solution is to do exactly this. So it's still a factory operation. Like this connection here, this is pretty brutal. It's big. Again, it's the kind of thing that in a factory you'd want to do. Make a big honking connection there, because you're going to do 1,000 of these maybe, and you don't want 100 of them failing because you did a sloppy job. So you do a super job, and on 1,000 of them, not one fails. That would be the objective. This could also be a note that was sent out about this radio, talking about this problem after it was manufactured. And so when the radio went in a repair shop, now I'm suggesting it went in a repair shop, they checked the bulletins and found that there was a bulletin to install this resistor. So they would go ahead and do it because they make a little bit of money doing that, and they have a justification. They have a bulletin from the manufacturer, even if the radio wasn't oscillating. And I'm only guessing about the oscillation problem. Okay, well, so the simplest things become really complicated, it seems. And that's probably just the way life goes, isn't it? Well, I can't see any harm in leaving the resistor there and just replacing the capacitor. But I don't even know I'm going to do that. I don't know that for sure yet, because we haven't done any of the tests. So I certainly know where to test. So the DC voltage here with respect to the chassis should be 0. If it's not 0, it means a certain amount of charge is leaking through this capacitor, building up here faster than it can drain out through the 500,000 ohm resistor. So we'll test here. We should see a 0. Now the other thing to test was and find is the probably that guy right there. We want to find the cathode resistor. So the cathode is hooked up to pin number 8. Let's use this camera again here. Pin number 8. Pin number 8 is this one, and it does have this large resistor hooked up to it. So this will be the cathode resistor. Now if I want to read the value of that resistor, you know, body and dot. Body and dot. So orange, maybe this way. Maybe it's orange this way, white, and then brown. So I would make that out to be 38 plus 10, 380 ohms. That's what I figured out to be. I could be wrong. I get things mixed up once in a while. Talking about mixed up, where's my voltmeter? Here it is. We will read the ohmage on there. Let's see if it's anything like what I just figured out. I'm trying to remember what I saw in the schematic. I think it was the same amount. There we are. We're talking resistance here. Futile. Okay. On the resistor, we get on the resistor. We get, whoops, come on, 438, so it's gone high, and that's from 380 to 438. It's not the end of the world, but that's a little high. A little high there. What that would do is it would increase the bias on the tube and reduce its current flow. Whether it would really, well, I guess what it means though is you can't max out the tube. You can't turn the volume up and get the absolute max out of the tube before you run into too much distortion. I think that might be the way to put it. Is that a serious problem? I don't think so. If it were low, I think I'd be more concerned. It's gone a little high. It's going to slow down. Hey, let's look in the book. Of course, by this point, I've closed the book. I can't help myself. 6F6. 6F6. EF. So we want to look at some typical operation here. Typical operation. Plate supply voltage, incidentally. 250, 285, 250, 285. So just under 300. This is the plate voltage. Probably true on most of these tubes are going to be running, well, that voltage or less. And what am I doing? Looking for cathode bias resistor. 410 or 440. Wow. Okay, so it's recommending. The book here is recommending a higher value than the 380. So I'm not going to worry about that. Yeah, you can say, well, it's going high, so it's going to go even higher. Maybe not. Maybe it's relaxed into a steady state now. You know, came out of the factory and ran for so many years and eventually got there nice and maybe. Or maybe it's you know, getting worse and worse and worse, and it's going to get worse and worse faster. Maybe it's going to go off. I suppose if I was going to operate this radio, you know, 24/7, I'd be a little more concerned about stuff like that. So, okay, cathode resistor good. The bypass capacitor must be part of the main filter capacitor in the radio. And where is it hiding? It's right up in here. It's just right up where I'm pointing. It's the main capacitor, filter capacitor. There's going to be a wire then going from this terminal. You can see it here, up to the filter capacitor there. Okay, I think we're ready to do some tests. I'm going to stop, drink a little coffee. We'll be using the my favorite voltmeter here when we get back, and we'll poke around. We will poke around. Okay, here we go. Voltmeter set. We're on the 500 volt scale, so I'm going to try to measure the B plus first. We're ready to start up the radio. There we go. There we really go. You can kind of see the dim bulb there, which I'm going to get rid of. And we want to make sure we're operating the radio with, you know, close to the correct voltage here. 109 is a little low. Hello, radio. Why so quiet? Oh, another dirty control. That one was quitting the sound. Oh, quitting the sound. How could this? This is the tone control. How could it quit the sound? Don't know. Can you hear a little hiss? it's hooked up to the signal generator. So that's probably why it's so quiet. We'll leave it like that. 109 volts. Try to stay focused, Jim. Go up to like 115, somewhere around there. That's good. That's good. Okay, first thing, B+, what are you? So I would like to contact, turn on my headlight here, the oh, that's just, you know what, this capacitor actually doesn't have terminals. It has wires coming out of it, and one of them goes right over to this big busy terminal here. Oh, I'm blinded by the light. This big honking terminal here. Surprising it's that noisy. So on the 500 volt scale, that's showing 200 volts. Sounds low to me. Now there's another big honking terminal here. What's on this one? That's better. 310 volts. Okay, now we'll go down to the output tube. The output tube should have the highest plate voltage. Not necessarily, but often it does. And the plate, which one was the plate? The plate was, cathode was 8. I don't know what the plate was. Okay, open the book again. 6F. 6F6. Plate is on 3. So look at the plate voltage on the output tube. How much of the 300 and something gets there? 1, 2, 3. 3. Only 200. So it looks like what we've got is we've probably got 2 capacitors in the filter, and in between is the field coil of the radio, of the speaker. Now, on one side we're getting the high 300 and something, and on the other side we're getting only 200 and something. That's an awfully large drop. All that is dropping in the speaker field coil. Doesn't sound very good to me. I would think you'd want more voltage on the plate here. How the field coil drops too much voltage, I don't know how that can happen. It's a bunch of wire. Okay, we're just making observations here. Let's pick another tube that's bound to have a reasonable output voltage. And I certainly don't want to. We want to do this one up here. So I'm just going to go around. I don't even know which tube is it. I'm not, it's a 6SA7. I'm just going to go around. We'll just watch the voltmeter here and see what we get. I'm starting on pin number 1. Nothing. 2. Ooh, hot diggity dog. 3. So 3 gives us 200 volts. So that'll be the plate there. Pretty sure there's a screen here. This is probably the screen at 100 volts. The information I have does not contain any information about voltage. This is probably the grid, judging by the fact that this is going negative ever so slightly. I lost track of where I was. It was here. Was I here? I lost track. Was I here? Yeah. So loud noise coming out of the speaker, and the meter being driven negative a couple volts or so. And that's the last one there. So we found plate voltage 200, screen voltage 100, and down here maybe I should go all around on the output tube. Let's do that. So we'll start with pin number 1 all the way around here. 0, 0. Interesting. I'm surprised that touching these causes a sound like, yeah, I don't know if you can hear it, but there's a much more hiss. Ooh. Ooh. Oh. Oh, 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 oh. Somebody's loose. Probably a tube is loose. I have not Have I? I guess I pulled all the tubes. Oh yeah, I did all that. Where's the noise coming from? So let me get a little bit of a somewhat massive stick here. And we're going to beat the radio up a bit. Is it the volume control? It's probably this. We got to deal with this noisy control here. Wow. Okay, let's fix that. I'm trying to power off. I got to turn the radio right around so that because the entrance is here and hard to spray uphill. Short on the speaker wire here. Ooh, what was that? That was a sad sound. What was that? Just some debris getting crushed. Yeah. Okay, now spin her around. And let's get the magic elixir. Here. The control rafter is this one. That was quite a bit. I put quite a bit in there. Okay, we've got the radio tipped up this way. It's plenty stable. We're going to leave it this way. Or is that going to confuse me if I start seeing it upside down and right side up? Doesn't take much to confuse me, so I'm going to flip this the way I had it. Back in. Okay, power the radio back up. We'll find out if that was the noise. Ooh, I hear noise already. So that's a lot better. That was the noise. Still a little noisy in the volume control. You know, so this noise in the volume control could be from DC leakage through the volume control, and you can't clean it away. That's possible. Okay, we were doing voltage tests, and I got distracted by the noise. And what was I about to do? So we found that the B plus is like high B plus is available, but it's not making it to the tube. Maybe that's normal. Maybe that's intentional. I would think that's going to heat this speaker up. I'm checking its temperature here quite a bit. The field coils do get warm. Those speakers do get warm, but they should not get hot, that's for sure. Okay, next thing to take a look at then is this blocking capacitor leaking voltage? So the first thing we'll do is we'll look on the high side, and we should see some high voltage here. What am I doing wrong? What's going wrong? Oh, I know what's going wrong. I took off the ground lead. And have my meter completely connected. Let's try it again. There we go. We should see something like 200 volts here. Ooh, that's not much at all. So that would be 50 volts. Is something weird going on here? How's that happen? How do you have 50 volts? Oh yeah, that's right. That's right. That's the plate voltage of the detector tube, which is normally low. 50 is very low. I think usually a little higher than that. Well, I could call that 60. 60 sounds like it's probably correct. Let's put this on another scale here. 150 volt scale, 60 volts is about here. Yeah, right on 60. And the meter, I calibrated that meter not too long ago. There's no reason for me to think it's not correct. Now we're going to read on the other side of the capacitor here. And there should be 0. It should be 0. Let's watch. Did you see it? Did you see it jump up a little bit? So what can happen here is some charge gets through the capacitor, charges up this end of the capacitor. Yes, the charge is leaking down the 500,000 ohm resistor, but it's leaking in fast enough that a pressure is developing right here. We can read the pressure. Now the problem is, it's a very high impedance circuit. 500,000 ohms going one way. If I take my 10 million ohm meter and apply it, I will draw some of the charge off. Did I say 500,000? Yeah. Let's see. So what that would look like is, I've made the meter more sensitive here. The meter will jump up and then come back as the charge bleeds up into my meter. Let's take a look. Watch carefully on the meter now. In fact, just watch that meter. Oh. Okay, so I kind of blew the test here because I'm not getting a good connection. Give it a moment, and here we go. Well, okay, that went a little farther than I expected. This is indicating a serious problem here. That's what it's indicating. 50 volts, 50 volt scale, and we've got 20 volts positive on that grid. Am I crazy? Is that true? Can a radio even work like that? 20 volts positive. That's bad. That's bad. What am I looking in here for? I don't know. I'm beside myself because I'm worried now that something bad's happening right in front of me. EF6F6. So that that might explain the low plate voltage, maybe. I want to double check. The grid is pin number 5. I just want to be absolutely sure what I'm doing here. Grid is pin number 5. Turn on the eye blaster light. Pin number 5. And counting here. Clearly 1, 2, 3, 4. This is pin number 5. It's the same pin. The same positive voltage. Think about this now, Jim. You're making a mistake, aren't you? You're reading this to the chassis. There should be 0 to the chassis. I'm not making a mistake. If you look at the voltage drop on the cathode resistor, it's all suspiciously similar voltage. 22 volts. 22 volts. What's happening here? Something not right. That's for sure. That's for sure. Okay, we'll kind of cut the power. Okay, so those readings I just took, they're kind of extreme. Typically, I have found only a couple of volts positive on the output to grid, not 20 volts positive. Well, the obvious thing to do, we would change this one capacitor, see what the result is in terms of the voltage on this side of it. If I am making a crazy mistake here, maybe we'll still see the voltage. I think if I put a new capacitor here, the voltage reading on this will be 0. I'm going to go and consult with my coffee cup, and then I will change that capacitor, and then we will see. The schematic contains the capacitor sizes for the different capacitors that are in the radio, except for this one. This is the one I just cut out. This is the grid blocking capacitor for the output tube. On the schematic it shows the capacitor, but no value. So in looking at it, under the dirt here, it looks like 0.01, pretty sure. And it's in not the best looking shape on the outside. Let's give it a test and see what's going on with it. So the interesting thing I find in doing this work with a radio that's operating well is finding problems that seem to be serious, yet the radio is operating well. Seems to be, anyway. Hidden problems you cannot tell exist. So certainly the heavy excess current going through the output tube because of a bad capacitor here is a problem that you can only detect when it gets bad enough, or it'll waste your output tube. That's the problem. I didn't really say that. The extra current will wear out the cathode that much faster. Okay. If I can get this down a little bit, I don't know. A little bit. Okay, you can see the pi I. Here we go. What will it do? So it's not opening at all. So this is a very leaky capacitor. Now that adds up with what I found in terms of voltage. You know what else? Maybe that. No, I was going to say maybe that extra resistor is somehow involved in this. No, I don't think so. So I'm going to put a 0.01 in there. 0.01, 0.02, 0.05 probably all work fine. 0.01 is what this is, though. So we'll follow their lead, whoever they are. Okay, new capacitor is installed. Let's get ready to read the voltage again. Okay, power on through the dim bulbs. Very good. I wonder if this has had an effect on the B plus reading I would get on the plate. We'll check that too. Give the radio a moment here. Gotta give it the full treatment. Are you there? I've quieted these things down so much. Yes. Seems very quiet, doesn't it? Didn't it seem quiet? Okay, now we're going to read this. First, the supply side. And we'll put this up to 500 volts on the supply side. Again, 150 volts. There's nothing there. Like it's just, this isn't good. That's all of 70 volts. Oh, that's right. That's a plate of, yes, okay, 70 volts. Right. Now on this side, here we go. We should see nothing. And we see nothing. This is 1.5 volts now. We should see something on this. Can you see it move? It's moving the needle width, basically. It's not much more than that. There's always going to be a little bit of voltage on this, but it's virtually zero. Excellent. So changing that capacitor has stopped the debiasing of the output tube. Oh, that's not stop here. Keep going with the voltage. Oh, my phone is ringing. I got it right. Bit of a family emergency happening here.